Have you ever wondered how powerful black holes really are? We know that even light cannot get out of their depths, but a black hole attracting 6 galaxies at once is something absolutely fantastic. And one monster 1,000 times larger than the Sun has managed to do it, spreading its web 300 times larger than the Milky Way. But we still know so little about black holes that even this may be just the tip of the iceberg. What if black holes hide entire universes inside them? And what if we actually live in one of them? No one can look inside a black hole, at least because human life is not long enough to make this possible. As you approach any black hole monster, the gravitational field grows tremendously. And as it increases, time slows down more and more. Under such circumstances, an observer can only see the interior of a black hole after an infinite amount of time. But even if it was somehow possible to speed up this process, we still wouldn't be able to penetrate a black hole. Let's suppose that one desperate researcher decided to make such a journey. He would first have to make a way through an accretion disk that surrounds a black hole. This region of glowing gas rotates at the speed of light. It's also incredibly heated by the friction of matter that gets absorbed by the black hole. So it would instantly incinerate the curious researcher. Although according to one theory, accretion disks of electrically charged black holes are cooled by quantum noise. If so, the researcher would probably be able to pass this region without getting fried or being torn into atoms. But then, if this was a small black hole, he wouldn't survive because of its powerful gravity. But scientists say that in huge black holes, gravity is weaker. And if so, perhaps the researcher might have witnessed a whole universe inside such a giant. But we'd never know for sure. Black holes have enormous mass. The Sun at that density would be the size of New York City, and the Earth would be smaller than a peanut. The gravitational force of such massive space objects doesn't allow matter or even light to escape them. For a long time, scientists believed that there was nothing inside black holes except for dust, the remains of stars, planets, and galaxies not yet digested by these monsters. But recently, cosmologists found out things that are not that simple with electrically charged rotating black holes. Under certain conditions, photons, other particles, and possibly large celestial bodies, such as planets, can rotate in their wombs. This led scientists to believe that space inside a superconducting black hole is being stretched and deformed, and this happens at different speeds and in all directions, just like our expanding universe. But this is not the only similarity. Dr. Nikodem Poplawski decided to look for other analogies between black holes and our universe. According to the standard model of cosmology, the universe was born from a singularity as a result of the Big Bang. This is a point where the laws of physics known to us stop working. But we don't know where this point with such an unimaginable amount of energy and compressed matter came from. Poplawski suggested that it originated from a black hole. Scientists think that black holes also have singularities where all their absorbed matter is compressed to its maximum. The scientist compares this point of infinite density and gravity with a seed. According to his theory, such a seed is trillions of times smaller than any particle known to us, but it's still divisible. When matter is compressed to a critical size, a seed bursts, and particles fly out in all directions. They form stars, planets, and galaxies. 13.8 billion years ago, our universe might have formed from just such a seed. So it could be possible that we now live inside a black hole of another larger universe. And meanwhile, new worlds could be forming inside our giant black holes. Recently, there appeared to be a new twist to the scientist's theory. He suggested that universes don't remain in black holes after their birth. The idea is that a black hole grows and pushes a universe out of itself while maintaining a connection with a new world. This is somewhat similar to a common route connecting two trees, but a black hole and a new universe are connected by a wormhole. It's created at the bottom of a black hole due to the pressure of a spinning seed of singularity. When this seed bursts, its energy and matter are fired into the wormhole, and then a white hole or a new universe is created on the other side of a black hole. According to Poplawski, there should be a constant expansion happening inside white holes. Meanwhile, black holes in our universe bear seeds of new worlds. The scientist offers theoretical and experimental evidence for his hypothesis. He demonstrated the origin of a universe in a black hole with a simple example of two plastic bottles. In a somewhat similar way, a black hole fills the space of a white hole with matter and energy through a wormhole. He also provided a more scientifically based proof of the hypothesis, supported by the known fact of rotation of all galaxies, stars, black holes, and planets in our universe. A similar phenomenon should occur in a primordial universe. This means that our outer space must have the rotation parameters of a black hole from which it emerged. In a black hole, rotation is spiral, so a number of galaxies should be twisted to the left, while the others to the right. And according to scientists at the University of Michigan, this is exactly what happens. In one part of the universe, the majority of galaxies spin to the left, but in the other part, the right-hand rotation prevails. Another surprising hypothesis was suggested by three scientists from the Perimeter Institute for Theoretical Physics. They believe that our universe could have come from a black hole in a higher fourth dimension. We're known to exist in three-dimensional space, but the gaseous accretion disks of black holes are considered two-dimensional. So why can't our universe be a three-dimensional disk of a four-dimensional black hole? The idea is that a huge star from a 4D space exploded and turned into a four-dimensional black hole. So the accretion disk of the monster became three-dimensional. Matter got inside of it, which, after the flash, was not absorbed by the black hole. Something similar happens during supernova explosions when stars scatter their remnants over the surrounding space, and 2D worlds can be hidden in two-dimensional disks of black holes in our universe. We cannot see a four-dimensional world and a parent black hole in it. Scientists suggest that 4D objects would be like incomprehensible clumps of matter to us, and creatures from a 2D daughter universe can only see strange cross-sectional bands of matter in a 3D world. However, the researchers hope to test their theory with a new model of the universe. The gravitational influence of 4D space, according to their calculations, should cause fluctuations in the background radiation, the one that arose immediately after the Big Bang. Now science makes it possible to detect the spectra of this radiation and its changes. Based on these fluctuations, the team of researchers hopes to establish the probability of the existence of a four-dimensional universe. Cosmologists around the globe are also trying to discover the secrets of black holes with the help of new technologies. In 2022, astronomers saw how a black hole, instead of extinguishing, lighted up stars in the dwarf galaxy Heinz 210. And to test their craziest theories, scientists are building holographic, 3D, and other models of space monsters. Researchers from Israel have learned how to make microscopic artificial black holes from rubidium. So far, their experiments have confirmed Stephen Hawking's theory that radiation emanates from the interior of a black hole. Now they want to find out the exact nature of this phenomenon. Over time, they may be able to determine other properties of black holes more accurately, currently only known in theory. They hope to create more black holes in the Large Hadron Collider, and these objects would be 1,000 times smaller than a proton. In a fraction of a second, they're likely to evaporate or disappear into space. But this is a significant step in studying the incredible properties of black holes. Maybe one day, they'll find entire universes hidden inside them, and when they do, we'll make sure to tell you about it. Scientists have finally done what was once thought impossible. They captured the first image of black hole. But now that black holes have become easier to spot, researchers have found one hiding very close to Earth. Is it dangerous? Is it headed our way? Are there any other black holes out there lurking close to us? In case you're not familiar with these great devourers of the universe, black holes form when massive stars 8 to 15 times more massive than the Sun collapse after running out of fuel. Some create powerful supernova that eject material outward in all directions at almost the speed of light. But some stars simply collapse into dark black holes without a supernova. During collapse, the core of the star begins to compress its gravitational center without ever stopping. The newly formed black hole becomes so dense that its gravitational forces become incredibly strong, pulling it into any object that comes too close. The forces of gravity in a black hole are so strong that even light cannot escape it. And now it's just been discovered that there's a black hole just 1,000 light-years from Earth. Located in the Telescopium constellation near Sagittarius, it's the closest black hole to the planet Earth ever found. By comparison, the black hole at the center of the Milky Way is 25,000 light-years away. This black hole might be too close for comfort. While 1,000 light-years might sound distant, in cosmic distances, it's very close. It's so close that you can see the star system without a telescope from the southern hemisphere on a dark, clear night with the naked eye. HR 6819 is a triple binary system that is made up of two stars that orbit a black hole. At first, it was thought that this was a simple binary system with just two stars orbiting each other. But after analyzing the data, something very unusual was found about the behavior of the inner star of HR 6819. The velocity of this star was so extreme that the astronomers suspected a third object must be sitting close, by which was flinging the stars around like a slingshot with incredible force. European astronomers finally found evidence for a mysterious, large, invisible object with a mass estimated to be 4.2 times the mass of the Sun by tracking the two companion stars using the MPG ESO 2.2-meter telescope at ESO's La Silla Observatory in Chile. To everyone's surprise, it was found that the two stars were actually orbiting a stellar mass black hole, around 25 miles in diameter, that was formed by the gravitational collapse of a star. The inner star, whose orbit is shown in blue, and the black hole in red look as though they're chasing each other. But they're actually orbiting each other. The inner star completes a loop every 40 days, while the outer star travels on a wider orbit. Is this black hole dangerous? Upon further study, the hidden black hole in HR 6819 was found to be one of the very first stellar mass black holes that do not interact violently with its environment, and therefore appears truly black. Is it moving towards us? While this black hole is really close to Earth in terms of space, it poses no harm to Earth at the present time and is not moving through space. You may be wondering if there are any other black holes hiding out there, just waiting to suck up our solar system. The discovery of the black hole in HR 6819 so close to Earth is just the beginning and provides clues about where we might find other black holes in the Milky Way. It's estimated there may be hundreds of millions of these universe eaters, and astronomers have spotted around a couple of dozen black holes in our galaxy. But that isn't the first time that a black hole has been found lurking close to Earth. But before we're able to directly image black holes, the only way they could be detected was if the black hole was feeding. This creates a ring of fire, called an accretion disk, that's caused by heavy gravitational and frictional forces compressing and heating the matter of a star or planet as it falls into the black hole. Before the black hole in HR 6819 was discovered, the next closest black hole to Earth was V616 Monocerotis, which is 3,000 light-years away. V616 Mon is around 9 to 13 times larger than the Sun, and previously you could only see this black hole because it's located in a binary star system that's close to a detectable star that moves in a unique pattern and is orbiting the black hole. Because it has a lot of mass, it has an incredibly strong gravitational pull. Cygnus X1 is another black hole that's close to Earth and is actually considered the first black hole discovered. It was first found in the constellation Cygnus in 1964. It's also famous because the late great astrophysicist Stephen Hawking bet another physicist that it wasn't a black hole. But Hawking lost the bet, and in 2011 it was established as a black hole. Cygnus X1 has 14.8 times the solar mass of the Sun, but only measures 18 miles wide. It lies about 6,070 light-years away from us, and is the most brilliant, high-energy X-ray source in the heavens. It spins at 800 revolutions per second, and is sucking the gas from a closely orbiting supergiant blue star, which has a size of 19.2 solar masses and is 300,000 times brighter than the Sun. The gas heats as it's getting sucked into the black hole, forming an accretion disk and emitting bursts of high-energy X-rays and gamma rays through jets. here's a video about what's happening with Cygnus X1 and the super blue giant. For a long time, we could only guess what a black hole must really look like, since it's nearly impossible to image an object that light cannot escape from. But technology has been advancing by leaps and bounds, and on April 10, 2019, astronomers obtained the first ever image of a black hole located in a galaxy called Messier 87. In the image, you can see the bright halo of gas surrounding the dark object in the center. But it's not just any black hole. It's a monster that measures 24 billion miles across. That's 3 million times the size of Earth, and has a mass 6.5 billion times of the Sun. It could quite possibly be the biggest black hole that exists. But thankfully this giant monster is 53.49 million light-years away, or 16.4 million passes from Earth. How the photograph was taken is an incredible feat. Scientists always thought they could image a black hole by capturing their shadows against the glowing surroundings. But this technology wasn't available until now. Everyone knows that the larger a telescope, the greater its ability to gather more light, and the higher its resolution will be. So how do you create the largest telescope in the world so it can image a black hole? A team was put together to take on this challenge and created a network of an array of smaller telescopes that can all be synchronized to focus on the same object in space at the same time. They call this the Event Horizon Telescope and have improved upon imaging faraway objects, which is known as the Very Long Baseline Interferometry technique. This new powerful telescope is as large as the distance between the two farthest telescope stations. One is at the South Pole and the other in Spain, which created an aperture nearly the same diameter of Earth, about 24,901 miles. This same team is now working on trying to image the supermassive black hole at the center of our own galaxy, Sagittarius A star, which is 4.1 million times the size of the Sun. However, therein lies a great mystery, because for some unknown reason, the ring of fire around the black hole at the heart of the Milky Way is smaller and dimmer. Since we now have the technology to directly image black holes now, there's a good chance we could find them hiding everywhere. There definitely could be a black hole even closer to us than 1,000 light-years. But black holes are still notoriously difficult to detect, which makes them dangerous because you don't need to be that close to be affected. A black hole can reach out through light-years with its incredible gravitational forces, and if a planet gets too close, it could be obliterated, vaporized, or flung into an entirely new area of space. It's been discovered that black holes like the stellar mass HR 6819 can move. Rapidly moving black holes that are flying through space are essentially impossible to detect because space is very big. Could a black hole be heading our way? The truth is, no one would know until it might be too late. And if you can see stars being warped from a black hole, you're already too close. But for now, there isn't anything to worry about. In the meantime, if you want to try and find HR 6819, use a star map or star map application and find the constellation of Telescopium. It'll appear as a single bright object since the two stars are so close together. Of course, you won't be able to see the black hole itself, but you can know you're staring right at it. As technology and methods improve, closer black holes to Earth will inevitably be discovered. Astronomers are always looking at the universe and discovering new planets, stars, and other amazing things that blow our minds. Now scientists have recently found an incredibly bright and mysterious light that's nearly as old as the universe itself. But what is it that they found? And why is the light from this massive object so bright? In 2019, astronomers discovered a 13 billion-year-old light coming from a distant quasar. Quasars are massive and extremely remote celestial objects that emit incredibly large amounts of energy and typically look like a star when viewed through a telescope. But it is what lies at the heart of the quasar's light that's the most impressive. It's said that quasars contain massive black holes and may represent a stage in the evolution of galaxies. And what they found amazed and surprised everyone. a massive black hole that formed so early in the universe that it would have to have an incredibly huge solar mass amount, and mysteriously, it was created 100 million years after the Big Bang. It was given the indigenous Hawaiian name Paniuaena to honor its discovery from Mauna Kea. The quasar provides scientists with an idea of what the universe looked like millions of years ago. What can astronomers learn from this black hole, and what does this mean for the future of the universe? The name Paniuaena translates to unseen spinning source of creation surrounding with brilliance, and was captured by astronomers using the University of Hawaii's Institute for Astronomy's Pan-STARRS 1 telescope on the island of Maui. The nearly 6-foot diameter telescope is safely stored in the summit of Haleakala. It features the world's largest digital camera with almost 1.4 billion pixels and is a real treasure to employees at NASA. The data collected by the Pan-STARRS 1 telescope. But it took a lot more than just looking through a telescope to find this massive black hole. The W.M. Keck Observatory provided the near-infrared Echolate spectrograph to confirm the existence of Paniuaena. The over 32-foot optical infrared telescope includes a suite of advanced instruments from multi-object spectrographs to integral field spectrometers to a world-leading laser guide star adaptive optics system. In addition to the near-infrared Echolate spectrograph, astronomers also utilized the GNIRS instrument in the GEMINI observatory. Once the presence of Paniuaena was established by both tools, scientists began to understand the incredible magnitude of this discovery. There's so much more to unveil with Paniuaena than any previous quasar. Quasars are known to give off an immense amount of light energy, but Paniuaena is especially brilliant compared to those spotted previously. A quasar found in 2018, known by the name J1342+0928, pales in comparison to both the glow and size of Paniuaena. Spectroscopic observations unveiled the black hole hosted by this quasar contains a mass 1.5 billion times that of the Sun. That's what makes Paniuaena especially unique. It's the only known object in the universe that has the capacity to host a black hole that's greater than 100 billion solar masses. This created another missing puzzle piece in the enigma that is Paniuaena. In order for this quasar to grow into such enormous power, it was most likely born approximately 100 million years after the Big Bang. This begs the question, how can the universe produce such a massive black hole so early in its history? Typically, a black hole of such size would grow from a smaller black hole that originated from the destruction of a star. However, Paniuaena disproves that such a theory is relevant in this circumstance and instead suggests that the black hole started off as a 10,000 solar mass seed black hole. The creation of galaxies and stars is believed to have begun during the epoch of reionization around 400 million years after the Big Bang. The ionization of hydrogen gas led to the development of the first quasars and black holes. Before the epoch of reionization, there was no source of light present in the universe since radiation was typically consumed by hydrogen gas. Now, with the confirmed existence of Paniuaena, researchers have the opportunity to further explore the process of reionization to gain greater insight into the development of black holes. The quasar has been described as a cosmic lighthouse. As its light travels the long journey toward Earth, its spectrum is altered by diffuse gas in the intergalactic medium, which allowed researchers to pinpoint when the epoch of reionization occurred. The massive nature of this black hole is almost entirely incomprehensible, making it difficult to truly comprehend its significance. Scientists are able to calculate the mass of such a black hole by studying the movement of stars in the center of various galaxies. By evaluating the speed of these stars, we can understand the mass of the black holes themselves. These formations grow so large from absorbing immense amounts of gas over billions of years. They consume everything that crosses their path, and their incredible size creates more opportunities for them to swallow up any object in their gravity. As these objects are dragged into the black hole's pull, they're heated to millions of degrees, which results in glowing X-ray light. Nothing can escape the strength of a black hole's gravity. Nothing. However, scientists have only been able to spot a few young cosmos, despite thousands of galaxies existing in the closest universe. Since the illumination from the X-ray takes time to travel, studying these areas of the universe requires astronomers to virtually look back in time. There are two main theories as to how black holes are formed. One theory suggests that black holes originated from the first generation of stars. These stars, made up of helium and hydrogen, quickly developed into enormous beings that were possibly hundreds of times the size of the Sun. They did not last very long in the universe though, and their collapsed cores were all that was left after their inevitable death from titanic supernova explosions. Thus, a black hole was born from their leftover cores. The second theory works off the premise that black holes are not related to stars whatsoever. The first black holes were actually a result of unstable clouds of gas that eventually collapsed. This theory explains how the existence of gigantic black holes can be dated back to millions of years ago. Scientists continue to grapple with these two opposing theories, illustrating just how little we know about the origins of these great, bestial black holes. With the largest black hole in the known universe containing a mass 66 billion times than that of the Sun, known by the name Ton 618, the magnitude of these entities continues to baffle scientists. Fortunately, astronomers are not completely clueless about black holes in our universe. For starters, NASA has determined that it's impossible for a black hole to swallow up an entire galaxy on its own. Although their gravitational pull is quite powerful, it's not substantial enough to ingest an entire universe. No black hole is located close enough to our solar system to pull any object in, but scientists have studied what the potential consequences of falling into a black hole would be by observing stars. While stars that fall into their gravitational pull are ripped apart, humans would experience a process known as spaghettification. The strength of a black hole would stretch one's body vertically while simultaneously compressing it horizontally. Both the perception of time and space are altered when falling through a black hole. While outsiders would only be able to catch a glimpse of the exterior of the mass, the person experiencing the fall would suffer a warped idea of what reality means. With the Sun being the largest star in our solar system, some used to fear that it could explode and create a black hole that would inevitably suck everything into its gravity. But have no fear, the Sun is not large enough to explode and will instead become a white dwarf. Even the hypothetical explosion of this star would not create a black hole large enough to swallow the planet Earth. The Sun's gravitational strength would remain stagnant, meaning that our planet would continue to revolve around it as normal. While we do not have to fret about a black hole consuming Earth anytime soon, the creation of black holes undeniably affects all living things that reside on our planet. When black holes collide, elements such as oxygen and carbon are released into the universe. These elements can potentially contribute to the future creation of planets. Stars and entire solar systems can be formed by shock waves from stellar explosions that lead to black holes. The connection between black holes and galaxies is still unclear. Astronomers are not entirely sure whether the development of a black hole eventually led to the Milky Way galaxy, or if the Milky Way actually came first. However, it's clear that black holes did contribute in some way to our solar system, even if it's not entirely clear how. This means that everything we know and everything we are is due to the creation of black holes in the universe millions of years ago. Famous physicist Stephen Hawking determined that though the overwhelming presence of black holes is intimidating, black holes cannot remain in their massive states forever. Known as Hawking radiation, small amounts of energy are lost due to the nature of the vacuum. The vacuum is not actually ever empty, as particles are constantly entering and exiting. When a pair of such particles approach a black hole, one has the opportunity to escape as the other is sucked into the gravitational force of the entity. The energy that allows one particle to enter space and get away comes from the black hole itself, meaning that the black hole loses part of its mass in the process. Since this process is slow, black holes that make up the universe are expected to remain for millions or billions of years before shrinking. NASA has confirmed that while the black hole in the Milky Way galaxy seems threatening with a mass of a few million times that of the Sun, there is no chance of it consuming the planet Earth anytime soon. At this point, it swallowed almost all of the stars in its gravitational pull. Even if it's able to ingest a few more stars, it only has the capacity to grow in small increments. Galaxy collisions could potentially cause black holes to expand, but it's highly unlikely that these events would disrupt the balance in our solar system. Remember that Paniua is the second most distant quasar discovered. No matter how ravenous and powerful it may be, it remains very far away from Earth. Hold on right there. This isn't just another black hole video. We all know nothing can escape it. We get it already. But is it possible for something to escape a black hole? And if you fell into one, what would really happen? The answer is probably going to surprise you, and it's not what you think. Also, new research shows that what we thought was a black hole in the middle of the Milky Way galaxy might not even be a black hole at all. So, what is it? A tesseract full of bookshelves? Or maybe the home of Cthulhu? Or perhaps it's something far more mysterious. It's pretty safe to say that we have no idea what a black hole is, what's going on inside, or if it's something else completely. It's not like we can directly image one, but at least we can now get images of their huge shadows in space. In 2019, astronomers grabbed the first ever image of a black hole, and a new polarized image shows powerful magnetic fields wrapping around a huge black hole shadow. This supermassive black hole is some 55 million light-years away from us and is bigger than the entire solar system. We're going to use this massive black hole for a simulation that involves you and a friend, but we'll get to that in a bit. You know the whole thing about nothing being able to escape a black hole? Well, is this really true? When a black hole eats up a star or a bunch of gas, they generate a powerful flow of high-energy particles close to the event horizon, the ring of fire called Hawking radiation at the edge. And if a black hole is really chewing on something, like a massive star, powerful X-ray jets shoot out, and the black hole becomes a quasar, the brightest objects in the universe. Who says light can't escape it? Well, now we have another argument about nothing being able to escape a hungry black hole. This is because astronomers captured a neutron star in an elliptical orbit around a black hole that survived being swallowed completely. However, the dead star didn't get away from the black hole unscathed. Astronomers captured images of massive X-ray flares being belched out by the black hole as it was eating the star's material. The star is trapped on a 9-hour elliptical orbit around the black hole, and at its closest orbit, the black hole rips off more of the star's material and becomes bigger. It will try hard to get away, but there's no escape, as the black hole will eat it more and more until there's nothing left. So now we all understand how powerful a black hole can be, even swallowing each other. Now you might be wondering what the closest one to Earth is, and if we're in any danger of a black hole eating us sometime soon. Just recently, scientists discovered one of the smallest black holes ever found, and it just so happens it's also the closest to Earth. Astronomers have named it the Unicorn, because so far it's the only one of its kind, and it's in the constellation Monoceros the Unicorn. It's about 3 times the mass of our Sun, which is tiny for a black hole. And it's about 1,500 light-years from Earth, which means you don't need to worry. It's not going to come and swallow us up anytime soon. That's because black holes don't usually move and sit in one place, eating up everything that gets too close to them. But that doesn't mean they can't move. And here's a scary thought. In 2021, researchers got a big surprise when they discovered a supermassive black hole racing across the universe at 177,000 kilometers per hour. The big mystery is that astronomers don't know why the black hole, which is 3 million times heavier than our Sun, is speeding through the center of the galaxy about 230 million light-years away. Now, that sounds crazy, and it sounds fast, but in 2017, scientists clocked another supermassive black hole hurtling through space at 7.2 million kilometers per hour. An enormous force would have to be responsible to get these things moving through space that fast. Maybe what we are seeing is the result of 2 black holes colliding, the massive collision sending the other flying wildly through space. So now we've all learned what happens when something gets too close and is sucked into a black hole. So what happens to a person, and could you survive the trip? Now we've all heard that if you somehow get sucked into a black hole, you would be stretched out or spaghettified, maybe even crushed or, well, you get the idea. Now this might be true if the black hole was small enough, but a black hole, let's say 30 to 100 times more massive than the Sun? That's where reality becomes really strange. The moment you entered a black hole, reality would split you in 2, or clone you. In one of these realities, you would be incinerated, and in the other, you would plunge into the black hole and fall through it without being harmed. How is this possible, you ask? Well, a black hole is a place where the laws of physics break down. Einstein said that gravity warps space itself, causing it to curve, and space-time can become so warped that it twists in on itself. Yes, we know that's a lot for the mind to wrap around, so it's time for a thought experiment. In the beginning, we said we were going to run a simulation involving you and a friend. Let's say that you both signed up to go on an adventure to the nearest black hole. One of you will go in, and the other will be an observer. You've flipped the coin. Your friend is going to watch you in horror as you plunge toward the black hole while they remain floating away at a safe distance. Now, this is where it gets weird. As you accelerate towards the event horizon, your friend sees you stretch and contort as if they were looking at you through a giant magnifying glass. But as you get closer to the horizon, you appear to move in slow motion, and as you reach the horizon, you remain there, motionless, stretched across the surface of the horizon, and the heat begins to engulf you. Your friend sees you slowly obliterated by the stretching of space and the ring of fire called Hawking radiation. Before you get a chance to cross over into the darkness of the black hole, you are reduced to ash. Game over. But don't plan your funeral just yet. We need to view this scene from your point of view, because something even stranger happens. Nothing. That's right. From your perspective, you would sail straight into the ominous black hole without so much as a scratch. No slow stretching and no scalding Hawking radiation either. The reason is that you are in a free-for-all, and therefore you feel no gravity. If the black hole was smaller, you'd have a problem because the force of gravity would be stronger at your feet than your head and stretch you out like spaghetti. But something way more massive than our sun, the forces would be small enough you wouldn't notice them. But the sad and lonely part about this adventure is that you would live out the rest of your life pretty normally until you reached the singularity. But what's wrong with your friend? And why are they telling everyone that you've been barbecued to a crisp by radiation outside of the horizon while you're chilling inside the black hole? Actually, you really were burnt to a crisp at the horizon, and you are inside the black hole at the same time. This is because the laws of nature require that you remain outside the black hole as seen from your friend's perspective, and quantum physics demands that information can never be lost, and all information that accounts for your existence has to remain on the outside of the horizon. However, the laws of physics also require that you sail through the horizon without being fried by hot particles, otherwise you would be in violation of Einstein's theory of general relativity. Now, some of you are going to say, no way. And you have to admit, it's a conclusion that seems nonsensical. How can a black hole clone me, you're asking? Physicists called this mind-bending conundrum the black hole information paradox. But in reality, there's no paradox, because no one ever sees your clone. Your friend only sees one of you, and you only see yourself. Neither one of you can compare notes, and no one really knows what happens. And it doesn't matter if we try to send someone or some spacecraft inside of a black hole to relay back some data. Once inside, there will be no way for a signal to get out, and you'd be lost forever. But what an awesome trip it would be. So what about the mystery of the black hole in the middle of the Milky Way galaxy? For years, it was widely accepted that Sagittarius A is a black hole in the middle of the Milky Way galaxy. However, some astrophysicists from Italy now say the object, which is as big as 4 million suns, might not be a black hole after all. The reason is that a huge gas cloud came close to the black hole. The gravitational forces of Sagittarius A should have eaten the cloud, but the cloud of gas survived with an issue. Could it be the home of Cthulhu? Well, while we love to joke about this, the answer might just be as mysterious. Some scientists say that the center could be a big bundle of that incredibly elusive stuff they call dark matter, which is invisible and thought to account for 80% of the total matter in the universe, but cannot be detected because it doesn't interact with light. Now scientists have proposed that black holes themselves could be formed out of dark matter, which would explain why they can form so quickly before the galaxies around them. And one day, that might be proven to be true. There's hardly anything more bizarre in space than black holes. They're invisible and always hungry space phenomena. Some of them come in unimaginably large sizes. In fact, black holes can eat up so much matter that they keep growing nearly infinitely. So how are black holes different from what we imagine? What's the largest one that we've ever discovered? And how much bigger can they grow? To understand how black holes work, you need to understand gravity. To throw a ball to some height, you need to apply a certain amount of force. The same with rockets. Only they weigh a lot more than a ball does. A rocket's speed has to be greater than the gravitational attraction of the Earth. And this speed-to-gravity ratio is known as the escape velocity. The minimum speed needed for a rocket to escape our planet's gravity is at least 11.2 kilometers per second, or about 6.9 miles per second. But what is the escape velocity of a black hole? It's either the same as the speed of light or even greater. And since nothing can move faster than the speed of light, you can't escape a black hole once you're past its event horizon, the boundary of no return surrounding a black hole. But if black holes don't let any visible light out, how can we see them? Although black holes may seem like empty regions of space, they're anything but that. The fact that we can't see a black hole itself, but rather its influence on the surrounding matter, doesn't mean there's nothing inside one. This is due to its strong gravitational field. Anything inside a black hole is tightly packed and cannot get away. As a black hole's gravity attracts gas and matter, it creates a swirling area around it called an accretion disk. And because these different particles around a black hole move extremely fast, they start to heat up and emit X-rays and gamma rays. So, using scientific telescopes and satellites, we can actually detect those rays and assume there's a black hole out there. Another way to spot a black hole is to notice the weird motion of interstellar material and stars that might point to a strong gravitational field beside them. In fact, any object can become a black hole, but you need two major ingredients to make that happen: mass and high density. To make a black hole out of our Sun, you'd have to compress it to a radius of just 3 kilometers. And to make a black hole out of the Earth, you'd need to squish its mass into a sphere the size of a small pea, or less than 9 millimeters in radius. But do such tiny black holes even exist? In theory, there could be one-atom large black holes and even smaller ones. They're usually referred to as quantum black holes or primordial black holes, meaning the smallest of them could be born just after the Big Bang. But if these tiny black holes existed, they would have been harmless, evaporating instantly after their creation, as they'd be much hotter than our Sun. Some scientists speculate that primordial black holes could be one of the components of dark matter. But let's leave hypothetical primordial black holes behind and get down to the type of black holes we've been able to observe. We know that stellar black holes exist for sure, and they're usually formed when a massive star explodes with such power that it shines brighter than an entire galaxy of stars. The phenomenon is called a supernova. Now, similar to how we measure distance in space, which is the distance from Earth to the Sun, scientists use solar mass as a unit to measure the most massive objects in space, including black holes. And the mass of an ordinary stellar black hole is about 3 to 10 solar masses. Cygnus X1 is just an example of a stellar black hole and the first one we've discovered. Cygnus X1 is located in our galaxy roughly 7,000 light-years away from Earth. But what's interesting about it is that it spins nearly at its maximum rate, which is 800 times per second. Even though Cygnus X1 has 21 solar masses, it's still quite a small representative of black holes. Next come intermediate mass black holes, and their name speaks for themselves. For a long time, intermediate mass black holes were a missing gap for understanding black hole evolution, but soon everything might change. This type of black hole is already larger by a lot, as it can have a mass that's hundreds to thousands of times bigger than that of our Sun. In 2006, astronomers stumbled across powerful X-rays, and as you already know, it's one way to detect black holes hiding from our view. These X-rays were tracked to a dense star cluster in another galaxy, and based on the luminosity of the received signal, a black hole is estimated to be about 50,000 solar masses. While scientists still don't know if it's an intermediate mass black hole for sure, lots of signs are there. 50,000 solar masses may look like a big number, but that's almost nothing on a scale of supermassive black holes. One of those, as with most galaxies, sits right in the middle of the Milky Way. Sagittarius A star has a mind-boggling 4.6 million times more mass than the Sun. But it's only 17 times larger. In fact, it's not that big. It could actually sit within Mercury's orbit. Sagittarius A star is still located about 26,000 light-years away from us, so there's no threat to our planet or our solar system. In the meantime, there are supermassive black holes in some distant galaxies that act weird. Spotted and captured by NASA's Hubble telescope, this abnormally bright quasar named 3C186 is in a galaxy that sits 8 billion light-years away from Earth. Now, we already know that the central parts of most galaxies contain a supermassive black hole. But what astronomers found out about this black hole is it's not quite in the middle. In fact, it's located approximately 35,000 light-years away from the center of its galaxy, and that's further than our Sun is from the center of the Milky Way. So what could possibly move a black hole that weighs more than 1 billion suns? Scientists believe that about 1 to 2 billion years ago, there was a collision of two galaxies. As they collided, the central black holes of the two galaxies started to circle each other and eventually merged into one, creating powerful gravitational waves. As a result, a newly formed black hole was harshly kicked out in the direction opposite from the strongest gravitational waves. The power of such a kick was so immense, it could be compared to 100 million supernovae exploding all at once. 3C186 still keeps moving away at the speed of 7.5 million kilometers per hour. At this speed, it could travel from our planet to the Moon in roughly 3 minutes. The new black hole that was born should be much larger than 1 billion suns, but so far we have no idea how massive it could be. To grow that big, black holes need to feed on tons of stars. But don't misinterpret that, they're not space vacuum cleaners. If our Sun was suddenly replaced with a black hole having the exact same mass, there would be no change in the Earth's orbit, and we wouldn't be swallowed up by it, since its radius would be just 3 kilometers, so we'd have to be much closer to it than we currently are. Supermassive black holes are already hard to comprehend, but they're miniature compared to ultramassive black holes. One of the largest and most massive black holes ever discovered in this category would make Sagittarius A star look like a small asteroid placed next to our Sun. Within the huge galaxy Holm 15A, home to roughly 2 trillion solar masses, lies a black hole 40 billion times more massive than our Sun. To compare, it's more than half of the stars in our galaxy put together. Holm 15A sits 700 million light-years away from us, and a black hole in the heart of this galaxy equals the size of our entire solar system. Until recently, scientists believed that the upper limit for the mass of a luminous black hole was about 50 billion solar masses. Little did they know, a new discovery would change this. You may not know this, but the brightest objects in the universe aren't stars or galaxies. Quasars are. Not so long ago, a quasar with the brightness of 140 trillion suns named TON 618 was discovered. It's so bright that it outshines the entire galaxy it's located in, and the ultramassive black hole powering it is a real monster at 66 billion solar masses, which makes it even more massive than all the stars combined in the Milky Way. TON 618 has a diameter of 389.8 billion kilometers. The quasar is located in a distant constellation, Canis Venatici, some 10.4 billion light-years from us. Because TON 618 is so far away, its light takes more than 10 billion years to reach us. So we only see how big it was when the universe was just a few billion years old. And by this time, it could have grown a lot bigger. One idea is that for such a monstrous black hole to grow, there should have been a different black hole that served as a seed to feed a bigger one by merging with it. But computer simulations show this isn't what happened with TON 618. A more probable scenario would be multiple black holes merging together into one over time. Still, we don't know if that describes the story of how TON 618 formed, but it remains the most massive black hole we've discovered up to this date. So far, we keep finding new black holes that appear to be larger and larger each time, and scientists have even started suggesting there could be a new class of black holes named stupendously large black holes. These black holes could have a mass above 100 billion solar masses, and even a lot more than that. All of this begs the question, if black holes constantly grow, does this mean they're eternal? Well, on a scale of human life, the lifespan of our planet, our sun, and even our solar system, yes. Black holes slowly evaporate and lose a tiny bit of mass through a process called Hawking radiation. But the thing is, it's a very slow process. It'll take about the age of our universe for a black hole with a mass of 100 million tons to only lose 50% of its mass. And the bigger they are, the more this process slows down. Once all the stars fade out or explode, black holes will still be there for a very long time. By the way, if you'd like to see a video about this and how the universe will little by little freeze and die, let us know in the comments. The observable universe is roughly 46 billion light years in radius, so there's a lot more out there to surprise us. One day, we'll hopefully find something that could shed light on the dark, mysterious patches scattered out there in the skies. So far, it's like trying to guess what's behind a door, while only knowing what size the room could be and its temperature. We hope you enjoyed this video, and thanks for watching.